to gas laws, and today we're going to look at something called, a topic called Boyle's law, okay? So I want you guys to look at this carefully. It's a marshmallow inside a syringe. I got my finger at the end right there, and I'm going to push this syringe down and apply pressure to it. Now look carefully, very carefully at the marshmallow, see any changes or anything. See it shrinking, getting a little more wrinkly. It's kind of probably hard to see, right? Let me pull it back out. Let me try one more time. All right, let's push it down again. Now look carefully at the covering of the marshmallow. See if it gets a wrinkly or small or anything. I see that? Bam. Okay. It's kind of hard to see, but you know, there you go. Now guys, I was applying pressure, right? Okay, as I pushed the syringe down, okay? Now what happened to the volume of the marshmallow? Okay, it got smaller, got a little more wrinkled, right? So that essentially is Boyle's law. So let's look at it. All right, so we're in gas laws, and we are looking at Boyle's law, okay? Now we have, guys, the original gas law, or the combined gas law that we tend to use. The combined gas law is in the back of our reference table, all right? So what's the combined gas law? It's P1, V1 over T1 equals to P2, V2 over T2. Now guys, it's very important that you know what things mean, know what the variables mean, know what these subscripts mean before you venture into any kind of calculations, okay? Because then it'll get random and it's not gonna end up well. So the P stands for pressure, V is volume, and T is temperature, right? And I think it's in the back of your reference table on table T, it tells you that. But the subscripts, the ones, okay, the ones represent initial, okay? So I'll put it over here. The ones represent a number of things, okay? All the meaning the same thing. They represent the initial conditions, or the starting conditions, all right? Okay, or the old conditions, okay, the beginning, okay? Now, if you know one, you know the other, right? You know two. It's just the opposites. So two, these subscripts twos here mean that final condition of that variable, okay? Or the ending, okay? Or the new. So please know what these things mean, the subscripts and the actual letters, the P, the V, the T, the variables, know what they mean. Okay, so here's the key, guys. Boyle, right? He did experiments at constant temperature. Right? He did gas experiments at constant temperature. All right? Very important. Okay, so temperature is held constant, you know, not changing. So we discussed in class, right, that whatever variable is constant in this topic, we can change it into the number 1. Bam, bam, okay? Now it's gone, because anything divided by 1 is the same thing, right? So what are we left with now? We're left with this, okay? P1, V1 is equal to P2, V2, alrighty? So, what are we gonna do with this? We can do some actual simple calculations, right? But before we jump into any calculations, all right, let's do some more theory about it. So, let's say we have a container. All right? Now we did this example in class, but you know, it's a nice simple example. And it has a cover which you can manipulate, which you can push down, which you can push up. And we're going to push it down. We're going to apply normal atmospheric pressure, which is 1 atmosphere. Okay, let's put a couple of molecules in there. Alrighty. Okay, there's 6 of those guys, no problem. Okay, and let's say this guy is at a volume of 10 liters. Okay, and at a pressure of 1 atmosphere. Okay, so that's P. That's our P, and that's our V. Alrighty? Now, let's say now we apply a pressure, a new pressure, this time 2 atmospheres. Okay? We still have our 6 particles inside. Alrighty? But this time, what's going to happen on, oh goodness, 1, 2, 3, I can count. Alright? This time, the cover is going a bit more down. We're pressing it more down. And guys, Picasso, I am not, okay? So no problem. Alright, so please don't write me. The volume will be essentially half, right? So let me cover that up and put my 6 guys right there. Okay, so initially it's like this, and this is half. The volume is now 5.0 liters, okay? So use your imagination, 5.0 liters. We double the pressure, volume got cut in half. Okay, so this right here, folks, is the relationship, okay, that governs Boyle's law, okay? So what I'm going to write down now, it's a inverse, okay, and proportional relationship. Okay, relationship. Let me put a box around that. So what does that mean? Because guys, you have to know all these things. They can ask you which gas law has an inverse and proportional relationship. They can ask you what's the graph shape of a particular gas law, and so on. So you have to know these things, people. All right. So it's an inverse and proportional relationship, right? So what does that mean? As one variable goes up, the other variable is going to go down. So when we increase the pressure, notice the volume got decreased, right? No problem. And the fact that it's proportional, is that, for example, we here are doubling the pressure, right? Now look what happens to the volume. It gets cut in half, okay? And the opposite is true too. Let's say we increase the volume, okay? The pressure would be decreased in that same proportion, okay? So it's pretty cool. All right, no problem. Okay, so let's look at a graph. So this is our Boyle's law graph, okay, at constant temperature, constant T, down, okay? Boyle's law graph at constant temperature. Now we agreed, people, it's an inverse and proportional relationship, right? Now I'm going to draw a rough sketch of what the graph looks like, okay? It has a general shape called a hyperbola, okay, which is important to know, and looks generally like this, folks, all right? Now, I said before, artistry is not my forte, okay? But it looks like this, okay? Now, the thing is, you have to be able to interpret graphs, so it's simply, guys, I got my pressure pointer, is my volume, right? So as the pressure increases, volume is decreasing. So pressure increasing, volume decreasing, okay? Now if I go the opposite way, this way, and I'm decreasing the pressure, the volume goes up. So that's how you interpret it, guys, okay? Pressure increasing that way, volume decreases accordingly, all right? If you decrease the pressure, volume goes up, okay? So that's how you interpret this graph, all right? No problem. And one last thing in our introduction to Boyle's law is that any time, right, let's say you're doing an experiment and you're taking data down in the experiment for Boyle's law, constant temperature experiment, you will see that the pressure times the volume, right, will give you a relatively constant number. Now, what do I mean? Let's look over here at an example, right? So we have pressure 1 atmospheres, volume 10, right? So when you multiply those two guys, right, What's 1 times 10? You'll get 10, right? 10 atmosphere liters, yes? Now over here, different conditions, same container, but different conditions. You got pressure 2 atmospheres, volume 5.0. So you're gonna get what? You're gonna get 2 times 5, once again, 10 atmosphere liters, right? So the constant number here is 10, okay? All right, your proportionality constant, when you go to college, you'll call it that, but let's not worry about that, okay? So what you can do, you can actually predict, okay, what 2 numbers go here. Because if the pressure gets doubled again to 4, right, you can automatically assume that the volume will go to 2.5 based on the fact that it has an inverse and proportional relationship, right? It's a nice thing about it, okay? So this is our introduction to Boyle's law in terms of the theory of it. Next, we'll do some calculations to call it a day, okay? But Boyle's law, once again, think of the combined gas law, constant temperature, and you go from there, you manipulate these variables right here, okay? And make sure you know the graph, all right? And make sure you understand that PV gives you a constant number. Pressure and volume gives you a constant number for Boyle's law. All right, guys, as always, hard work with sacrifice equals success. Take care. We'll do some calculations with Boyle's law next. All right.